Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, in this particular video we're going to be looking at the AQA and it's from June 2018 and it's the paper 3. As I mentioned in the intro, please do stop the video, have a go at each of the questions. So we're going to start with question number 1 and we've got circle the decimal that is closest in value to 11/20. Well, the problem we've got with that is that, as it says, each of these are decimals and this is a fraction. So what I'm going to do is I'm going to convert that fraction into a decimal. Okay, now the way to do that is if I multiply top and bottom by 5, what I actually get is 55 out of 100. Now, as a decimal, that's actually going to be 0.55. Okay, hopefully you're all right with this. I do appreciate that's probably a slightly different way of doing things, but it kind of works for this type of thing. Or you could use a calculator, actually. I just remember this is a calculator question or paper. So 0.56 is the closest, and that's absolutely fine. Okay, next one is circle the list of all the integers that satisfy this inequality. So basically what we're saying is the numbers are not equal to -2, but they are going to be bigger than -2. So it's going to be either that one or that set, so not this one, okay? And it's going to be less than or equal to 4. So it's going to be not that one, it's going to be this one. So this one will satisfy the inequality because the value of x is bigger than -2 and less than or equal to 4. So it would be this one on this particular question. Okay, next one is number 3, circle the largest number. All right, these ones are just a little bit tricky sometimes, I think. You just got to be very careful that in the first bit it says 3.27 recurring. So if I make an extra couple of 7s there, then it just gives you some idea of the actual size of that number. It's the same with this one here, 3.27. Well, that's going to be 0, 0. This is 3.2770. Okay, and then the last one is another 7. So actually, if we look at these, the number which is going to be the biggest is 3.2777, not any of the others. Okay, so it's actually going to be this one. So sometimes I think the technique with those is quite useful just to make sure that you're kind of getting it right. Okay, so let's move on then to question number 4. Question number 4, the exterior angle of a regular decagon. Okay, well, the thing about this is you need to know that a decagon actually has 10 sides. Okay, you also need to know that all the angles of all the exterior angles of a regular shape add up to 360. So basically, if it's got 10 sides, each of those sides is going to be 36 degrees because they all total up to being 360, and 360 divided by 10 is going to be 36 degrees. Okay, now number 5. This takes a little bit of thinking about, but it is actually a 4-mark question. Okay, so A is a common factor of 72 and 120, B is a common multiple. Okay, the important thing about this is it says work out the highest possible. Well, the highest possible is going to be achieved by making sure that A is the biggest number or the largest number and B is going to be the smallest number. All right, so let's have a little look and see if we can work out the common factor or the highest common factor of 72 and 120? Well, there's a couple of different ways in which we can do this. So the way I would do it, and if you have a look on my channel, there's a few examples of this, as I would use factor trees, okay? And the way I do a factor tree is always the same. I always start with just dividing by 2 on the left-hand side. It just kind of makes my life a little bit easier, okay? And what we've got here is 72 is equal to 2 times 2 times 2 times 3 times 3. Okay, and actually, I'm going to write that down, I think. So 72 equals 2 times 2 times 2 times 3 times 3. Let's look also then at 120. Now, 120, again, I do exactly the same. Okay, it makes my life a whole lot easier just to divide by 2 or divide by 3 if you can't. Okay, so that's 15. I'm sorry, I'm running out of space here, and that's going to be 3 and 5. Okay, so the reason I'm circling them is because they are the prime factors. Okay, so I'm going to write that underneath. 120 equals 2 times 2 times 2 times 3 times 5. Now, what you'll notice is that I've deliberately put those into like a column so that one is above each of the other, because if I do that, it gives me the ability to figure out what are the common factors, okay? And these are the common factors for both 72 and 120. So therefore, the highest common factor is going to be all of these multiplied together. Highest common factor is 2 times 2 times 2 times 3. Okay, and that's going to give me 24. So in other words, what we're saying is that the biggest common factor of 72 and 120, the highest common factor, is going to be where the top number is going to be 24. Okay, let's have a look then at working out then the lowest common multiple of 6 and 9. Okay, well, you can kind of use your times tables, really. If you think about the LCM of 6 and 9, the lowest number it can be is going to be, if we look at 6, 12, 18, and then we do 9 and 18. Okay, so our normal sort of times tables. So 18 is going to be the number which is the lowest multiple of 6 and 9. In other words, that's the number that's going to go into here. Okay, so if we then calculate that, what we've actually got is 24 over 18. And I can reduce that to 4 over 3. So to answer this particular question, the highest possible value of A over B, which is where A is the largest and B is the smallest, is going to be 4 over 3. And that would be my answer to that particular question. Okay, a little bit tricky to follow, but hopefully you're okay with that one. All right, so let's have a look then at question 6. Question 6 is one of those similar shape type questions, and what it says is that A and B are similar. So in other words, they're exactly the same. The lengths are different. So in other words, where this is 5, this is going to be a multiple of 5. Okay, now in this particular case it says a scale factor of 1.5. So actually we could work out H as being 1.5 times 5. Well, 1.5 times 5 is going to be 7.5. Okay, in the same way that we could actually work out W, where we could say, well, actually that's going to be 9 divided by 1.5. So 9 divided by 1.5 is going to be 6. And actually, even though this particular question takes up a whole page, we've actually answered the questions fairly well, because it's a scale factor of 1.5, so all we've done is just multiplied through. So right at the very bottom here, we can say that X equals 54 degrees because it's a similar shape. So in a similar shape, this angle and this angle are going to be exactly the same. Okay, and the value of H is going to be 7.5 because this is multiplied by 1.5. Okay, and then also W is going to be 6 because this is 9 divided by 1.5. Now, you might want to put some notes onto these lines if you want to, but essentially that's showing you're working and would justify you getting your 3 marks. Okay, hope that's all right for you. It's a big lot of big question on the page for a very small amount of working. But let's move on then and have a look at the next one, which is going to be working with some interest rates. Okay, so we've got investment A and investment B. Basically, these types of questions do come up quite a bit. So if you're not sure about any of this, then have a look on the channel and you'll see that there are some playlists on compound interest, which is the second part here. And the first part here also will figure in some of those questions as well. So investment A, you save £150 per month for 2 years, and then 2.5% interest is added to the total amount saved. So in other words, what we're saying is that with investment A, okay, we're going to look at £150 multiplied by 24, because there's 24 months in 2 years, and that's going to equal 3,600. Okay, and then we're going to add 2.5%, so plus 2.5%. Okay, if we add 2.5% to that, that's going to be £90. So at the end of the 2-year period, that total investment is going to be worth £3,690. Okay, hopefully that's all right for you. Let's have a look then at the situation with B. Okay, well with B, this is compound interest. Now, again, there's a couple of ways of doing this. I tend to use the formula. If you're not sure, please do have a look at the playlists, and that will give you some idea of the formula. Other people might prefer to use a table, but as it's a calculator paper, we can simply say 3,500, which is the initial amount. And we're going to multiply by the multiplier, which is 103%. Okay, this is 103%. Okay, now the decimal equivalent to that is 1.03. And it's the power of 2 because it's actually 2 years. Okay, and if we plug that into a calculator, we're going to get £3,713.15p. Okay, so that's investment B. And then it says the important thing with these is that, you know, 4 marks, probably 3 marks at this particular point, because they want you to answer the question, how much more is investment B worth than investment A? So we need to do this subtraction. So we need to do £3,713.15, take away this, and that's going to give us a difference of, okay, £23.15p. Okay, so in other words, investment B is worth £20.15p more than investment A after the 3 years. Okay, hope that's all right for you and you're able to kind of follow that through. Okay, let's have a look then at question number 8. So we're running at a fairly good pace at this moment. Please do, as I say, stop the video, have a go at these questions. Number 8a is going to be, show that the lines y equals 3x plus 7 and that one are parallel, and it says do not use a graphical method. Okay, all right, so the important thing with this one is to recognize with the first equation, this one, then actually 3 is the value of the gradient. Okay, so what we've got with number 3, y equals 3x plus 7, is basically, it's in the form of y equals mx plus c. Now, again, I might sort of describe it slightly differently to your teacher or another tutor, but basically m is the gradient, which is 3, and c is what they call the y-intercept. It's where it crosses through the y-axis. Hopefully you're familiar with these sort of things. And again, have a look at the playlist on the channel. There are some more examples. Okay, so in other words, if a line is parallel, now I know it says don't use a graphical method, but if a line is parallel, then it basically means that it's got the same gradient. Okay, so what we need to do is we need to change this into this form, and what we're looking at is the m value, mx, okay? And if when we change this, we get 3 here, then it means that it must be parallel. So let's have a look at doing that. All right, so at the moment, we've got 2y minus 6x equals 8. Well, that's no good to us. We need to make it y equals something. So I'm just going to write that as 2y minus 6x equals 8. Okay, we need to make that y equals something, exactly the same form as the first equation. Okay, so what I'm going to do is I'm going to get rid of this minus 6x, and the way I'm going to do that is I'm going to add 6x to both sides. So I'm going to get 2y equals 6x plus 8. Okay, now it's 2 values of y, so in order for us to get one single value of y, I've got to divide both sides by 2, and I'm going to get y equals 3x plus 4. So yes, they're absolutely parallel because this is 3 and this is 3, and you might want to put a line or something that says that both lines are therefore parallel. Okay, just be very careful of showing your working on these sorts of things, because obviously, you know, you could write that the lines are parallel but not show any working. Okay, but what we're saying here is that both lines are parallel because the gradient is the same. Now, my sketch is actually relatively accurate because you could say that this is 4 and this is 7, so this is the line of y equals 3x plus 4 and y equals 3x plus 7. Okay, hope that's been all right for you. As I say, please don't use the graphical method to do that. Do use an algebraic method to be able to manipulate that second equation. Okay, then it says, is the point minus 5, minus 6 above, below or on the line? Okay, tick one box. Alrighty, so bit of a tricky one really, because we need to have a look at when x equals minus 5. Okay, so let's have a look at when x equals minus 5 and we plug it into here. Now, if we do that, what it's going to do when we plug it in is give us a value of y. Now, at the moment, we could say y equals 3x plus 7. So, and this is when x equals minus 5, and that's important. Let's see what we come up with. When x equals minus 5, okay, we're going to plug it into this equation. I'm going to get 3 times minus 5 plus 7. Well, that's going to be minus 15 plus 7, which is where then y will equal minus 8. Okay, so therefore, the point minus 5 minus 6 is above minus 5 minus 8. Okay, so if you can imagine what that would look like on a graph of some sort. Okay, this is again only a bit of a sketch, but you've got that sort of thing where this is going to be 7. Okay, and this is minus 5 minus 8. So minus 5 minus 8 would be sort of down here somewhere. That's minus 8, okay? And this is minus 5 minus 6, so it's going to be minus 5 again, but this time only down to minus 6, okay? So it's going to be down there somewhere. Alrighty, so actually the point is minus 5 minus 6 is above the line. Okay, hope that's all right for you. Little bit tricky with these sorts of things. We're about 18 minutes into the video, so I think what we'll do is we'll have a go at the next question, which is question number 9, and then we'll probably leave it there. I hope that's okay, and we'll finish the video at around about 20 minutes. Okay, so the cost of a ticket increases by 10%. All right, so what it means is if we're going to work out the original cost, it means that the cost of the ticket now is 110% more than the cost of the original ticket, okay, because it's increased by 10%. So what we're saying is £19.25 is equal to 110% of the price of the original. Okay. All right. So the original was 100%. Then we increased it by 10%. And we came out with £19.25. And what we're being asked to do is to find the actual original cost. Well, being mathematicians, what we do is we don't worry about any of that stuff. What we do is we change it to a little bit of algebra and just make it a little bit more mathematical in its approach. So we've got 1925, and rather than writing 110%, we're going to use a decimal. I'm going to write that as 1.1, okay, which is 110% as a decimal, okay, and then rather than writing of the price of the original, I'm just going to write N. Okay, the normal price. Okay, so if I want to then find out the value of N, I just divide both sides by 1.1. So divide by 1.1 and divide by 1.1. Okay, and that will give me N on its own, which is the normal price, and that's going to be £17.50. So the original price was £17.50 for this particular ticket. Okay, that's almost exactly 20 minutes, so that's not too bad, is it? Appreciate there would have been the intro there, but I think we'll leave it there if that's okay, and we'll start again in the next video from question number 10 onwards. If you're not sure about anything, please do add a comment below. I'll always come back to you. Have a look at some of the other playlists within the channel, and I'll look forward to seeing you inside the next video.